So the recording is being saved, and yeah, here we go. So here we go, take two. What we're going to do now is we are going to, I'm going to briefly go over significant digits with you, since significant digits is like I said, it is a bit of a trick for a lot of people. So there we go. Okay, so first off, yeah, there's stuff I got to do. So first off, we determine the decimal places based on the quality of the tools used is the first true or false thing that we've got here. Okay. Now, if you looked at the measuring thing, you know that the bigger the tool, the better the tool, the more decimals you have, which means the tools do make the decimals. So that's totally true. Math done with measurements should maintain the quality of the tools used. Well, if the tools are telling us how good the measurements are, and we do math with those measurements, we probably should keep in mind the tool's quality. If we had a crappy tool, we really can't trust our answers as much as if we had a really good tool. So that's also a true. All results must be reconfigured to show the quality of tools. Well, if you believe the second one, you kind of got to do the third one. But the real tricky one is this. Your results must be based on the lowest quality tools, the lowest quality measurements, and then tools to preserve trust in those numbers. This is a tough concept for many people to think about because if you get a bunch of different stuff with different tools, then what can you trust, what can't you trust, and should you take the best tool you use or the worst tool? Well, the fact of the matter is the worst. If you were guessing the worst, you are absolutely correct. That is exactly what you should be taking care of. Now, I do a bit of a demo with a jug, and if I fill a large jug with water, I get a measurement, then I add a much smaller, more accurate measurement, and it basically disappears in the jug. I should be making a video of this to show it, but I don't have it quite yet. So as you can see, there's a lot of stuff. I'm trying to get you as many videos as possible of me doing stuff, even though there's lots of good stuff already on like YouTube and whatnot, which I've given you links for. So significant digits are trusted numbers from proper measurements. We consider these reliable. This is super important. This is exactly what they are. They're also called significant figures. It's about 50-50 whether you call them significant digits or significant figures. I call them significant digits, as do a couple of the other chem teachers. I think one physics teacher calls them digits, the other one calls it figures, but either way. Again, this is kind of like the gist on this slide determines the accurate rounding of theoretical numbers while maintaining the precisions of the tools. Basically, it tells you what numbers you can trust, and you should use those trusted numbers in everything you do from then on. Other numbers are either placeholders to maintain their proper values, or they're just unreliable, and you should discard them. There are three rules. Three rules. Rule number one. All non-zero numbers are significant. If a number is not zero, that means we have to assume it came from a measurement, came from counting, came from a tool. As such, it is significant. As such, it matters. So this is easy. If you take a look here at, let's say this is 23 million, the 2 and the 3 are both significant because they're not zeros. So there's only 2 significant digits in this one. In this number here, there are 3 significant digits because there's those 3 non-zero numbers. And so we take some practice holding up fingers. There's 2 and there's 3. So this is just something that I do in class, but you can see there, everything that's not zero is significant. And I use red to catalog that in this PowerPoint. Now, rule 2 states that zeros between significant numbers are significant. For example, here, if you've got 400920000, you will notice that this 4 is significant, this 9 is significant, this 2 is significant. So what about these zeros in between? 0 can be a valid measurement, and it happens all the time. And in fact, it happens at least 1/10 of the time, statistically speaking. This means that all of these are significant. But these zeros afterward, these are just placeholders. They're just there trying to make it so that the number that we're dealing with is the proper weight, the proper strength. So as again, you can see the color coding. The red is rule 1, the green is rule 2. And this continues. Any 0 that's stuck between is significant. And you can like see that as it repeats repeatedly. Rule 3 is the hardest rule. Zeros after the decimal and after significant numbers are significant. Just like in measuring, we had those extra zeros at the end when it was a really high quality tool. This is how it works for significance. So as you see with this number here, you can see you've got the 1 and the 5. These are both significant, of course, but then you have this 0.0 at the end. And, you know, as you saw with measuring, these 0.0s are only done if we actually measure to that amount. We don't add random 0.0s to places. As such, that means that the 1 and the 5 are definitely significant, and the 0.0, specifically the 0, is significant, which means that all this stuff in between is also significant, judging by the next rule. So, oh good, I do have ink color. Took me a minute to find. Okay, so and all of this would be rule 2. I was about to say, why can I not change the color? I can't. It's just in a different place than I'm used to. All right, so in that case, you can see here that all of this is significant. Rule 1, rule 3 at the end, and then rule 2 fills everything in. Look, pro tip, if you see a 0.0, the whole bloody thing is significant. There is no reason why not to put a 0.0 at the end if that 0 was not measured. It is a very common trick that teachers, professors, and sometimes even the world uses, in that a 0.0 exists to let you know the whole thing is significant. Now over here we have a much smaller number. As you can see, we have our 2 and our 7 are indeed significant, just like they normally are. And we then have some zeros after that. So see, you've got the decimal, and you've got other significant numbers here. Both of that together means those 2 zeros are significant. Without that to the effect, that wouldn't happen. So again, those 4 are. Now the zeros before, they're just placeholders, and they are not significant. Important, but not significant. So I know this is a lot, and trust me, people who are in class, they have enough trouble with as well. I'll see if I can dig up a couple of good videos, but this one's going so far so well. As you see here, you've got 4, and then this, again, you see that 0.0. Whenever you see 0.0, it's kind of like a code. This is all significant. Okay, so we just did the 3 rules. That is the 3 rules that govern significant digits. First trick. The first trick is we can put a decimal point to show that whole numbers are significant. And I use this all the time, and you'll see it all the time. As you see here, that dot only exists to let you know the whole thing's significant. This is only done with whole numbers that look like they have placeholders. This is something that happens a lot. So if you see that dot there, that's just letting you know the whole thing is significant. The dot itself is not a significant digit, but it's to let you know that the rest of it is. And you can see there, anything with a dot like that is, anything without a dot is not. And then you just go to normal. Okay, well, this is rule 1, and the others are nothing. I mean, you've got rule 1 here and then nothing. Not rule 2, not rule 3. Whereas before you had rule 1, and then this dot was your clue that the rest is also significant. So, you know, it's just one of the things that, you know, as time goes on, it'll get more comfortable, but it will take a while. Trick 2, if it's really hard, just put in scientific notation. Scientific notation is fantastic. I mean, if you look at this example here, you get all of these digits. Well, which ones can you trust? Well, it's based on how many digits did you start with. I started with 3 significant, 4 significant, which means my answer needs to be in 3 significant digits, which is really weird because that means that those are significant, but not the rest. And so it's like, what the heck is going on? How do I do this? How do I show that this one zero matters and the other zeros don't? Well, you put that in scientific notation. That's exactly what you do. In scientific notation, you can show the three things that matter and all the stuff that doesn't. And as you can see, anything that's not the times 10 is significant and the times 10 is not. Whew, that was a lot. But it does give a very nice kind of overview on how significance works. So there we go. Overall, there's your significance and there's your tricks. Okay, your non-zero 1 through 9 is significant. Anything between is significant, and zeros that are after the decimal and after other significant numbers are also significant. Decimals are great for significant whole numbers, and scientific notation for anything that's super hard. All right, so that's this. Now, there's all this practice, and you can see that you can do that. And if we had, if I had more capabilities, I might have you all like do video stuff and hold fingers up. But we are low on time as it is because I was trying to cram as much as possible into this. Now, yeah, we're not going to do that. Now, this is a nice little splash page to take a look at. If you have math that's multiply or divide, you want to use the least number of digits. So I started out in this example with 2 digits divided by 3 significant digits means my answer needs to be in 2 significant digits, whichever one's the worst. If we add and subtract, it actually gets harder because we have to go by number place, which is confusing and annoying, and you will be seeing a video on that later. Rarely, you will have both. And if you do both, you need to do order of operations. And again, a video will be coming there. The bigger one is when you're dealing with multiplication division, because that's the one that's going to happen all the time. As you look at this one here, why are you not showing up? Okay, it's fine. You don't have to show up. I can just click you. Okay, as you do this here, you've got 3 significant digits on this first one, because you've got that decimal that's saying I've got 3. This 6 over here is all by its lonesome, so you only have 1. That means this number here, you only can trust this 1. You can only trust 1 digit. So there's my 1 digit. The 2 is not strong enough to round up, because yes, rounding's a thing. And that means our answer is just going to be 4,000. Because we need our placeholders for each of these numbers that we don't care about. They are important, even if they are not significant. Now, that said, if I have 6.0, we still start with our 3. But now we have 2 significant digits here. Well, 2 is still less than 3 last I checked. But that means we can now trust 2 of these numbers, the 4 and the 2. The 6 then will successfully round up because the 6 is greater 5 or greater. Remember that whole thing, 5 or above, give it a shove. Well, 6 is above 5, so it gives it a shove. As such, you're going to deal with this becoming a placeholder, this remaining a placeholder, and the 2 becoming a 3. So your answer would be 4,300. Notice your final answer has more actual numbers, and thus it is a better, more trustworthy answer. Now for this last one here, we've got our 3 digits, and we have 3 digits again. That's fantastic. So we have 3 digits. The 0 cannot raise it up. It's just a placeholder anyway. And as such, the 4, the 2, and the 6 all matter. And we have our 0 placeholder to keep the number fine. So that is multiplying and dividing using significant digits. And hopefully that wasn't too confusing. Multiplying and dividing is a bit on the easy side. Do a bunch of practice and you're going to find that that's not terribly bad. Now, I've given you a bunch, so we're going to take a little break from the presentation before I show you anything else to see if you have any questions. real quick. I'm sorry that I don't necessarily see if you raise your hand, but please raise your hand whenever anything comes up. Do you have any questions for me at this time concerning significant digits? Because everything I just covered, that is the majority of what you're going to be dealing with. Okay, no problem. That was a decent amount, but there's more. So here we go, back to it. All right, so we are going to clear this. And since I've got a little bit more time left, when we do multiplication division, it's the least number of digits, which is what I showed you. And yeah, there's all sorts of neat stuff you can see there. I don't really care about that right now. Bunch of practice. Yeah. Okay. Really like went overboard the practice here. There we go. Okay. And trust me, when I redo this, there'll be far less practice built in there. You already have sample worksheets. When it comes to adding and subtracting, you're looking for the worst number place. You find the raw answer first, like you always should, but you're looking for the worst number place. And you can see this example here. So I'm really glad we got to had enough time to be able to go through this. I'm going to change my color to, actually, I think I'm going to change it to, yeah, I'll change it to blue. Okay, so basically it goes like this. Instead of counting the number of significant digits, what you're doing is you're seeing where they are. There's two ways to go about this. The first way to go about this, which is probably the best way, is to change it into an elementary school problem. If you change into an elementary school problem, being very careful that you are writing your stuff down in the proper number spaces, there's a neat little trick you can do. So I find it to be very helpful, especially as you are learning this, to just write everything down elementary style, where everything is in its space. Oh, what the heck just happened there? That was not fun. Let's okay, and erase. Okay, erase too much. Whatever. Okay. That was the bell here, but you guys still have another 5 minutes, so I'm just going to finish this up, and then we'll go from there. My other class can wait for a sec. So I wrote it all out elementary style. I do the line. I've got a plus and I've got a minus. So the first thing I'm going to do is I'm going to make sure that I get the raw answer. That means without having to worry about any sort of rounding, I'm literally just going to add and subtract what I've got here. All right, so 1500 plus 390 minus 110.5. As I get that answer, I get 177.9.5. That here is my raw answer. I'm just going to leave that there for now. So that is my raw answer. Now, what I can do is I can count. This here is significant. This one. This is significant for all of them, so we're good. This is significant for all of them. Notice it's 5, 3, and 1, and here's 1 and then nothing. So this is significant, this is significant. But over here, this is not significant. You get to this 0, and it is not significant. As such, you're going to slice straight down. All the stuff where the checks are, they work. All the stuffs outside the checks don't. Please wait in the hallway for now. Thank you very much. And as you see, that the 7 will round up the other 7, which means my final answer is going to be 1/8, and then placeholder. I don't know why it's doing that. That is very irritating. All right, now there is no 0.0 we're just going to leave it there at 1,800 because that's the answer. This is probably the best way to do it as you're learning. The other way to do it is you start at the beginning and then you go to where there is no more and you mark it. Start at the beginning, go to where there is, where the significance stops. Start at the beginning, go to where the significance stops. And then you sit there and you go, okay, here was the hundreds, meaning, there was the hundreds place was the last. This goes to the tens place. And this goes to the tenths, 1 decimal point. Okay, so what you want to deal with is the one that is the worst, meaning the biggest of these, that's the one that's going to win. That's the worst number place. So again, if you do your raw math and you get 1779.5, because you always get your raw first, you go to the hundreds, you go thousands, hundreds, and you stop. The 7 kicks it. 7 kicks the other 7 up, which means your final thing is 1,800. So there you go. That right there is an overview of significant digits and both sets of math. Now this was a lot. If you're feeling overwhelmed, that's because I just crammed like 2 or 3 days worth of stuff at you. But the reason I did that is because it's going to be recorded. You can watch and rewatch these recordings. I'm going to cut them up so that, you can only watch one piece or another. Because that's, I think, one of the best ways to go. Now, I would really like it if in the future you asked me any questions that you may have. But if you don't have any, then you don't have any. Hopefully you will. And remember, it is a bit more work taking care of doing this, at home. The benefit is you get to take it a little bit more at your own pace, but please, please, please don't put things off. Do your best to stay on track and email me constantly. Email me with every little worry, every little concern. I will text you. I will email you back. I will send links as appropriate. I'm here to help you, and I really do want you to succeed. If you have any questions, please send me an email or raise your hand, but our time, unfortunately, is up. I will see you all on Friday. You will have a quiz on Friday. It will be graded. I do have office hours both today at 4 p.m. and Thursday at 4 p.m. that you use the same link that you will always use. If you have any questions, please shoot me an email. I do have kids waiting at the door there. And thanks for attending. It shall be logged. Have a good day. Peace.